I would like to start by thanking you to coming to AMD San Jose. Welcome to California. And it's a pleasure to having you here. And I know that many of you travel very far to come here, so thank you. And I want to take a moment to highlight the amazing, outstanding year that Xen had in automotive. So we had the last Xen Summit in Lisbon in June last year. Since then, this is all that happened in automotive with Xen in automotive in the last span of time from the last Xen Summit. So AMD achieved the safety concept approval, which is a really big deal, and I'll tell you more about it in a few slides. Honda joined Xen project, Renesas joined Xen project. Automotive grade Linux announced a new Xen-based stack, a big collaboration between us, between Xen project and automotive grade Linux. And Ford joined Xen project. So this is such an outstanding year that I think we should really take a moment to really focus about what a big stride the project made, the community made since last Xen Summit. And because I see many new faces in the room and also online, I wanted to take 5 minutes from the presentation to actually do an intro, which was not supposed to be the topic of my presentation, but given that we're still at the beginning of the session, of the 3-day sessions, I think it's going to help many of the people in the room to understand better what we are doing with Xen in automotive and how it has been used. So on the slide, you see a link that is to my presentation last year. That was more like an intro, right? So I'm going to try to summarize it in 5 minutes. So what are we doing? So Xen is very flexible, like Cody said, and it can span in its configurations all the way from the more simpler real-time static partitioning configuration, such as industrial or Vision Hub in the car, all the way to more, richer, more interesting, sophisticated configuration, such as IVI. And it's a spectrum, so you'll be able to mix and match depending on your specific use case. So Xen runs entirely and only in its own privilege mode, a higher privilege mode, depending on the architecture, is called differently. And it has control over a few key hardware blocks, such as the timer, the interrupt controller, the MMU, the IOMMU, the PCI root complex, and the CPU. And this is pretty much an exhaustive list, because everything else is assigned to either one VM or the other, and by default is assigned to DOM0. And we'll see how this is changing, and now the DOM0 concept is becoming more and more flexible, or even disappearing, depending on configuration. But one big point here is there is full alignment now, at least in automotive and embedded, between x86, ARM, and even RISC-V deployments, in the sense that there are interesting architectural differences between the three in Xen. But when it comes to automotive deployment, especially on x86, where we use PVH, and we use Virtio for virtual devices, and I'll talk a lot about more about it. The architecture are extremely similar. And in fact, one thing that I want to highlight is something I discussed last year, and we made definitely progress in that area, is how farther along AMD x86 came in the last year, and is more at the same level of ARM now in terms of architectural support. I'm not sure why this is happening. All right. And as an example, with completion of PVH, now the domain types are very similar between ARM and x86. We support U-boot on x86 as well. We have UEFI bootloaders in guest on ARM and x86, as both of them. We have DOM0/hyperlaunch, is the same feature on both ARM and x86, and it shares a lot of code, and especially it shares the same configuration language. So you can configure the system the same way and boot on both architecture, and hopefully also on RISC-V soon. And the PCI root complex driver now is in Xen, and the same driver is shared across all architectures. So that brings the Xen support for all arches very, very similar, in a very, very similar way. One interesting thing that we're going to look at in the future is also one-to-one mapping of DOM0, so that you can start a DOM0 PVH on x86 on system without an IOMMU, which today will not work right. And also cache isolation, that's possible on ARM, but not on x86 today, cache coloring. All right, now just to go back to this slide and add a bit more details. So these are some of the details that I spent more time last year to highlight what are the two extremes and how you can mix and match. So starting on the right side, the simpler, you have DOM0S or hyperlaunch. You use it to statically partition the system into multiple domains. All hardware is passed through, so device assignment to either one domain or the other. You have even fully dedicated physical core to virtual core, so you take away scheduling to have better interrupt latency, better real time. We have demonstrated less than 3 microsecond latency under heavy interference on ARM, and we're working on that also on x86 now. We have a minimal footprint of Xen at runtime, like trying to, becoming almost invisible after the system has been started. And we even have Xen running on Cortex R52 and R82, and there is a presentation from Luca and Ian this summit about running on this microcontroller really that don't have even an MMU. So no page table, no at all. And Virtio is available, but it's not really heavily used. It's maybe rarely used. The opposite side of the spectrum, we have DOM0S hyperlaunch. Yes, it's used, and partitioning, yes, but mostly to boot faster, right? Everyone wants the car to come up with the infotainment system as soon as you turn the key. You don't want to wait. We also have a lot of Virtio support, and all of these are deployed in production from, well, not MPU, but all of the other are deployed in production, like VirtioNet, block, GPU, sound, media, TE, GPIO, I2C, input, right? And pass-through here is available, but it's not as heavily used as in the opposite end of the scale, the industrial case. And you can mix and match as much as you like. Okay, so one more word before I move to the new 2025 content. We have at AMD both ARM and x86 and for automotive use cases. And on the right, you see an ARM system for a vision hub like camera processing. On the left is an x86 system for IVI. And sometimes we even have both coexisting on the same solution, connected over PCI. And Edgar will talk about our work that he did with Virtio, so that you can have a VM on x86 on or the ARM side with backend across the PCI link on the other end. And the VM doesn't even need to know whether the Virtio backend is local or remote across cluster with the same ISA or a different ISA. So, people really love this abstraction because it proves that the VMs are completely abstracted from the underlying hardware, so much so they don't even know where the backend is running. Okay, moving forward to 2025. So what I want to talk to you about is our major progress on safety. So Senthil is in the room, is sitting back there, is a safety manager for our project, and he can answer your question if you have any. We are working on making Xen safety certifiable ISO 26262 ASIL D, that is the strictest for automotive. We have already talked about this in the past, so this is not new. What is new is the project is divided into 2 phases. Phase 1 is the safety concept, and phase 2 is the final assessment. And the phase 1 completed in November 2024 successfully. And this is a very major achievement. What this is because this project, in general, safety projects are so large, so critical, and so difficult, to de-risk the project and make it more manageable, you usually divide it in 2. And first, as a first step, you share with the assessors example of all your artifacts and all of your plans and techniques and strategies to reach safety. You have a review from the assessors, and then they give you their stamp of approval if everything goes well. But this is a major achievement, because then the second phase becomes just execution, right? So you have already given its example and the plans, and you significantly de-risk the overall project. So this was successfully passed in November 24. So these are the features that are in scope for our safety project. So we have no OS hypervisor dependency, meaning you can run any OS that you want on Xen. You can have one or more than one safety critical domains. Obviously, all the core drivers in Xen, like the interrupt controller, the MMU, and so on, they are all part of the safety scope. Static configuration, so dom0/hyperlaunch is part of our scope. So all the domain creation happens at boot time with predefined domains, as you know, including domain amount of memory, number of CPU, and device assignment. We do support domain reboot. Now, this is new. The patch series has not hit the Xen devel yet. I just did, you know, the review for the first time of the code 2 weeks ago. But this is about rebooting a domain without destroying and recreating the domain. So you do an internal reset of the state of the domain, keeping the memory as it is. This is critical because the memory deallocation and reallocation causes a lot of, you know, dynamicity and unwanted potential side effects on the system. By instead keeping everything in place, it de-risks the reboot significantly and the effect of the overall system. Pass-through of both PCI and non-PCI devices is in scope. Schedulers, or even better, no schedulers, is in scope. And the rest of the talk is actually on these two remaining points, which is the domain roles and the communication between domains. And before I get into that, I want to mention a couple of key points that, you know, about safety certification. What is really the safety certification about? It's about the quality of the code, obviously, and you need to test, you know, every line of code needs to be tested. There is an enormous amount of test and documentation needs to be written. That's one part. And the other part is really freedom from interference. You need to ensure that one VM cannot cause interference to the other. And I mean, as defined is, you know, one software element cannot affect the behavior, execution, data of another software element in a way that will violate its safety requirement. In other words, in short, no interference between VMs. Then there is another concept that is common in safety, which is a safety monitor. What is a safety monitor? A software or hardware element that supervises the operation of a safety-related system. It's someone that checks that everything is working correctly and potentially rebooting something that crashed. So we need to be able to run a safety monitor, potentially even inside a VM, and detect if another VM crashed and restart it. What is a QM element? This is often, you might hear me saying wrongly, unsafe VM, right? This is not the correct terminology. The correct terminology is QM, quality managed VM. So it is a component developed under standard quality management process, meaning not safety certified, with no ISO level assigned, again, not safety certified, because it has no direct impact on functional safety. I mean, this is obvious. You can keep a domain that is not safety certified, but it cannot have impact on functional safety, such as if in your system audio is safety critical, you can have the non-safe VM affect your audio system, right? All right, so what does it mean for us? First of all, what is clear is Xen is in charge of isolation. This is something we're very familiar with. I mean, for decades now, what we try to do, even from a security perspective, is to have Xen in charge of isolation. Nothing new so far. Freedom from interference is a different word to say the same thing. We need to enforce freedom from interference. Ideally, all of the VM should operate without interference from other VMs. Okay, but if we have to make compromises, we cannot compromise on the safety critical VMs. So the safety critical VMs cannot suffer interference. We can operate with some level of planned interference. Like if we run the safety monitor in a VM, and if the safety monitor can detect a crash in another VM and restart the other VM, obviously that is interference, right? It means that the safety monitor can restart anything whenever it wants. So we can allow some level of interference depending on configuration, but this is planned interference. It's not, you know, unwanted interference. It's by design, not by accident. right? And this is some of conclusion that, that from my own experience working on this. So it's very easy to fall into the trap of thinking about safe and unsafe VMs. And this is maybe how a system integrator will actually think. But we are one step before the system integrator, right? We should not, think about, we should not provide high-level safe VM or unsafe VM configuration option. We should be more flexible than that. Then should not have an opinion on what is safe and unsafe because it's use case specific. And depending on the safety certification, depending on the vertical, depending on the safety requirement of the specific case, this might vary. So instead, we should think about domain capabilities and domain flags, such as hardware domain and control domain. And this is exactly what I'm going to talk to you about in this talk. All right, let me start from DOM0, quoting Spider-Man, from great powers come great responsibility, and DOM0 certainly has great powers. So DOM0 can do a lot in the system, right? It can do way more than just monitoring and restarting what's crashed. So this is an issue. And at a minimum, if we wanted to have a DOM0 in a safety critical system, we would want to restrict what DOM0 can do. But even after restricting what DOM0 can do, we run into another problem, which is DOM0 is typically not tiny. And this is because DOM0, by having all the hardware by default, it gets all the driver by default, and some drivers are massive. I mean, if you measure the code size of the kernel component alone of certain GPUs, that goes into millions of lines of code. Millions, that's one driver, right? So how do we solve this problem? We chop it off. Originally, I had a more controversial slide with a tombstone showing DOM0, but I thought it was bad taste. And instead, I replaced it with a less controversial picture of DOM0 being split into two blocks. And the two blocks are the hardware domain and the control domain. So the hardware domain has all the hardware by default. Also, the description of the hardware is more, closely derived by the host, like the ACPI tables come from the host ACPI tables, device tree come from the host device tree, but is not privileged. So for the people that are familiar with Xen in the room, is priv equal false, right? But you must be able to share still these devices with other VMs using Virtio or PV drivers, you name it. And then you have the control domain. The control domain doesn't have any hardware by default. So it can be tiny, it can be an RTOS, can be a unikernel, can be Unicraft, whatever you want, but is privileged. So it can do monitoring and so on. Now, this is one of the things, I already basically said this as the last Xen Summit. It sounds really good in theory, but the devil is in the details. So when you look at the details, you start asking yourself, wait a second, what operation can actually the control domain do? And even better, if you want to use Virtio in the hardware domain, don't you need privilege? So as soon as you scratch slightly under the surface, you immediately run into two pretty big questions. And this talk is about the answers to these questions. So for the control domain, so initially it's okay to have the control domain fully privileged and being able to do all the operations. But I think in reality, what we want is only the monitoring and the restart operation. So to be able to monitor who crashed and restart the domain that crashed. That was actually Jan during patch review the task. Wait a second, do you really want all the operation? And he was right. We don't want all the operations, right? Not only we don't want all the operation, but the operation that we don't want, probably they need to be config out, right? Because one of the principle of safety is everything that is in the build must be tested. So if you don't want this operation, we probably don't want to have them enabled at all, right? This is one of the question mark. We're running out of time. I already tell you in this talk to be able to talk about this problem, but one of the problem is how do we make it configurable so that we can do monitoring and config out everything else. That's one of the question mark to discuss maybe in a design session. But I have more details and maybe a full solution or a proposal of a full solution on the hardware domain side. So Virtio can cause interference, and that's because the way Virtio was designed is that the backend needs to be able to access all the memory of the front end. So the backend, just to disambiguate the terminology, the backend is also called device or emulator, and the front end is also called driver. Okay, so the backend can definitely cause interference. How do we solve this problem? Two solutions. One is a new untargetable domain flag, which means if you set a domain untargetable, then the backend cannot target the domain. So you are fencing off, you're isolating, protecting one VM, making it suitable to run safety critical software. So one solution is your safe VM are untargetable, and therefore there is no Virtio interference, but also there is no Virtio. A second solution is a safe Virtio new extension that Edgar will talk to you about in his talk. And I'm going to mention a little bit about also myself. All right, so this is just a basic
hardware domain.
One domain, always. So in this example, we have a hardware domain. This is basically, in terms of privilege, is slightly more than a DOMU, and I'll tell you in a second how. And we have the control domain on the side. The control domain is optional. The hardware domain is very highly desirable because it gets all the hardware by default. It gets annoying fast to not have a hardware domain because you have to specify every single device if it goes to one domain or the other. It's cumbersome to do, especially in an out-of-the-box configuration. It's not what almost anyone will want. All right, so VM-to-VM communication. So first of all, let me highlight that Virtio and PV driver are not the only way that we have for VMs to communicate with each other. We have simple static shared memory that Bertrand and his team developed back in the day at ARM, and you can statically define shared memory area, super simple, definitely possible to use between safe and non-safe VMs. You have Argo that was designed with security in mind from the beginning. There is Daniel here that knows quite a bit about Argo in the room. And that also is suitable, between safe and unsafe VM. I mean, easier to prove that it's suitable between safe and unsafe VMs. And then we get into Virtio. So, like I said, the problem with Virtio is the backend, by design, is assumed to be able to cause interference to the front end. So one solution, one mitigation, is this new targetable domain flag. You specified as part of the hyperlauncher device tree configuration. You say this domain is untargetable or is targetable. And if you set a domain as untargetable, then you cannot do foreign maps, okay, for the expert in the room, meaning, well, not just foreign map, any hypercode checks with a target domain will fail, right? So this domain will be fully isolated. Virtio will not work. You could still do Argo or pre-shared memory. Grant table even will work because those are voluntary hypercodes, right? So you share and you decide whether you accept the share or not, or event channels are okay because you can not bind the event channel or not unmask it. But things like foreign map that are forceful, they are blocked. Now, what is the other solution? I mean, this will leave you with a fully isolated, very safe VM, but also no Virtio frontends running there. What if you want to run the Virtio frontend in your safe VM? And this is where we have worked. I mean, first of all, Jürgen was actually at SUSE was spearheading this effort. What he did is added the support for the grant table to be used together with Virtio. That adds the voluntary memory sharing model on top of Virtio. It's a great first step, but only solve half of the problem. This is already upstreaming in Linux, in QEMU for the Virtio backend. There is no Xen needed. And it solved the issue of the memory mapping and foreign maps. But there is a second problem. many front-end Virtio operations are blocking. What do we mean by blocking? The front-end does the operation, the entire vCPU of the front-end blocks, waiting until something happens in the back-end, there is a reaction, and then starts again. So this is perfect to create interference. To create interference, you just need to do nothing. You know, it's the best way to, you know, the best interference creating system. So the solution is, well, there is new Virtio protocol to solve this problem, but we also made a tiny extension on the existing Virtio protocols, just 2 new registers that would allow non-blocking read and writes on top of regular Virtio, giving you non-blocking Virtio on top of the existing Virtio protocol. And Edgar will talk about this in his talk. So with these two like Virtio grants and with grants and non-blocking Virtio together, you have a Virtio that is potentially deployable between safe and non-safe VMs. At least will be at the same level of PV drivers. What are PV drivers? PV drivers are the old school ways to share devices in Xen, and they use grant table and event channel underneath, which is great because that we said is okay between safe and non-safe VMs. But they also have other issues, such as they require Xen store. Xen store needs to run somewhere. There is a ring buffer protocol that is not designed with best practices when it comes to interference. In a way, this is not unique to the PV drivers, because Virtio also has this thing called Virtio rings, which also are not designed with the best practices to avoid interference. Which is the reason why I would say, no matter what you do with PV or Virtio, definitely harden your front end and back ends. Make sure that they always mem copy out to the ring, work in your private copy, mem copy back to the ring, rather than working on the live copy of the indexes, because then you are subject to interference. There is a bunch of paper written on this from the 70s, so there is lots of docs to read if you want to learn, but there are, you know, known technique to solve this problem. Sensor placement, again, thanks to Jan for pointing this out under review. Initially, we thought it would be harder domain. It really depends on where you, if you have a safety certified, or you want, you know, or depending on your safety requirement, where you want to place the Xen store. And now with the latest version of JSON's patches is configurable. So depending on what your configuration is, you can have it in the control domain, hardware domain, or even a Xen store stub domain. So this is the slide for today. That summarizes, and I am at the end, so I'm not good. That summarizes all the configuration options that we have added to support everything that I said so far. So we have control domain and hardware domain capabilities to run a control domain or a hardware domain. We have a Xen store capability to run Xen store D. That could be together with the hardware domain or the control domain. We have device model capability. This is so that you can run the Virtio backends. Typically, you want to give this to the hardware domain, but you could also have Virtio driver domains thanks to this. You have the targetable, untargetable domain flag so that you can fully protect and isolate a safe VM. And then you have the safe Virtio configuration options, the Virtio and grant table and non-blocking Virtio. Both of them are dynamically discoverable. The other two instead are hyperlaunch/DOM zeroless configuration option per domain. And this is the summary, I mean, an example configuration that tried to put together all that we said so far. So you have the control domain optional, which has the control capability. Then you have a domain. This could be a safety certified VM, which has basically no extra capability, but is untargetable. You have the hardware domain that has the hardware capability, the device model capability, as the Xen store capability, and can be non-safety certified. Then you have a driver domain that, if it's Virtio, is having the device model capability so they can run Virtio backends. And then you have a regular domain with Virtio frontends, which is QM and has nothing special, so it's targetable. You will do the same, and if you have safe Virtio with the extension only without supporting regular Virtio, that doesn't even need the device model capability. And finally, also, if you do the same with PV drivers, also you don't need the device model capability because you're running PV backends that don't need it. I told you we will run out of time to talk about the future work. This is for the design session. So this is my last slide. I just want to highlight, in summary, we had a record-breaking year for the project in automotive. Really, I think we have the best hypervisor for embedded in automotive in terms of supporting mixed criticality, in terms of supporting time, any OS running multiple architecture, high quantum zero-less are key features, and now the hardware domain and control domain split. And I do invite you to talk to the AMD team, the AMD Xen team. They made all of this possible, and most of them, except for one, are here. So go talk to them and interact. And thank you for listening. Can I take one question, or it's too late? Up to you.
I can have one question. Anyone? Oh.
Hi, my name is Alex. For freedom from interference, is software enough to achieve that, or is there any platform capabilities that would do really well to help with that effort?
So the IOMMU is absolutely essential. That's the most important hardware block because it's absolutely required when you do device assignment. Other than that, no. Yeah. Any other questions?
Mark Douglas from ARM. I guess I'm a little concerned about the emergence of these SoCs that are
Heterogeneous.
Heterogeneous in the sense that you have like NXP has, you know, devices that have both ARM A class, you know, or that would be in all these traditional hypervisors out there that would just know about those cores rather than what you have with the real-time cores. What's managing, I've seen on projects where things come up and they want to grab the other IO and so on. What elegant suggested management do you guys have for that?
This is a great question, and thank you, Mark. So I want to highlight that here, so this is x86 side, and Xen is running on the x86 core, fine. Across the PCI link, on the ARM side, actually, even on our chips, like on NXP, we have both Cortex-A's and Cortex-R's, and we have Xen running everywhere here, on all three, on the same deployment, right? We have Xen on the x86 with IBI across PCI. This is now enter the camera processing system. We have Xen running on the Cortex-R and on the Cortex-A's.
Okay, so there's
right?
an element of Xen
Yes.
that's running on Cortex-R.
Yeah.
This is not coming in the future. It exists now.
Right.
Okay, so chat doesn't see it. But are those all in communication with each other?
So yeah, so to us, the answer is, first of all, the reason why we're running Xen everywhere, it makes it for a common configuration language across all three. For instance, device assignment is configured the same way across all ISAs, and there are two from ARM and one on x86, right? So across ISA, and RISC-V is going to work the same way. So all ISAs, same configuration language, right? This is a relatively easy part because it's just configuration. So you can assign things properly, and this makes it much easier to even have a single tool that configures the entire system because the configuration is the same language across all three. But the most important part, and that was the most difficult, this is one of the cases where I was really keen, and Edgar is the one that did the work and is sitting in the back, but solving the most difficult problem first, right? The configuration is not the most difficult problem. The most difficult problem is communication, right? And this is what, you know, with Virtio message, Bertrand and Bill and Edgar have been working on new Virtio protocol to enable this, as well as backward compatibility with safe Virtio work, so we can share across and make it look like it doesn't matter which ISA it is or whether it's local or across PCI. So this is an amazing value proposition because now you don't really need to know, you know, if you have a Xen VM on R or x86 or Cortex-A, Cortex-R, where is running, right? So that is basically our answer to your
And
question.
it's orthogonal to domain DOM list of DOM server.
It's orthogonal,
Okay,
yes.
So I can,
Yeah.
if I want to, okay. Good answer.
Thanks, everyone.